Have you ever been scrolling through Netflix or Instagram and wondered how they can show thousands of posts without your browser just giving up? If you try to load all the data at once using traditional functions, you would get this. That is a memory overload. Loading everything at once is inefficient and breaks the user experience. But what if a function could hit pause and give you just one piece of data and wait for you to ask for the next one? That's not a science fiction, that is a JavaScript generator. Let's look at a simple common problem. Loading users' timeline. Imagine they have 5000 posts. The eager way to fetch everything, create all the 5000 UI elements and dump them on the page. This is terrible. The user just has to sit and wait. But what if we could fetch just one page of post at a time, only when the user is ready for it? Let's build a generator for that. As you can notice, we made just two changes to our normal function. That asterisk makes it possible function. Look at this yield keyword. It's like a temporary return. It says here is one page of 10 posts. Now I will pause right here until you ask for the next one. Now this is the most important part. When we call post pager, it doesn't run the function. Not yet. Instead, it hands us back the special controller object, technically called an iterator. Think of it as a remote controller for our function. This remote has one main button, dot next method. Every time we press it, two things happen. The generator wakes up and runs its code only until it hits the next yield keyword. It then pauses and hands us back an object that tells what's going on. That object has two properties. Value. This is the data we yielded. In our case, it is the next page of 10 posts. The second property is done. This is a boolean. As long as the generator has more posts to give, done is false. The moment it is finished, done flips to true. This is how we know when to stop. We are in complete control. This is incredible. The generator is sleeping and holding its state, just waiting for us to call next. We are only doing the work for 10 posts we needed, exactly when we needed them. This is a lazy evaluation. We are not processing all 5000 posts and creating the UI components. We are processing them in small, manageable chunks. This is the exact principle behind the infinite scroll or pagination buttons. The browser stays fast and responsive, the memory usage stays low and stable. We can even connect this to a button in our HTML. This is beautiful. The logic is so clean. The generator keeps track of where it is in the list. So we don't have to manage a complex page number variable ourselves. As you can see, it is the perfect way to load the data exactly when the user requests it. So when do we use this? As you can see, we can use this for pagination and infinite scroll. It's a perfect tool for chunking the data for the UI. We can use this for handling the massive data sets. Imagine processing a 10 gigabytes of log file. You don't read the whole file into the memory. You create a generator that yields one line at a time. Your memory usage stays tiny. We can even use it for complex async workflows. The popular library Redux Saga uses generators to handle complex asynchronous logic in a way that looks clean and synchronous. It is a game changer for the state management. Okay, I have got a challenge for you to make this concept stick. Our post pager was finite generator. It stopped after 5000 posts. Your challenge is to build infinite generator. First, try building the Fibonacci sequence generator. It should yield one value at a time forever, every time when you call the next. And for a tougher one, try prime number generator that yields one value at a time forever. Both of these shows how generator perfectly remember its own state. Let me know in comments if you try this challenge or answer this. What is the biggest data set you have ever had to load on a single page? If you learned something new, hit that like button and subscribe for more deep dives into the professional JavaScript. Speaking of which, a generator function is a special type of function. But do you know how this works differently in a normal function versus an arrow function? That is the topic of my next video. Thanks for watching and happy coding.